Welcome back to another one of my sessions. In this session, we will be looking at cumulative frequency graphs. My question reads, the times in minutes for which 80 customers waited in a line at the bank are summarized in the table below. I have in this section here my waiting time, which is in minutes. I have my number of customers and my cumulative frequency column. Notice that there are values in your cumulative frequency column that is missing. The question asks, Part A, complete the cumulative frequency column to show the number of customers who waited for less than 5.5, 10.5, 15.5, etc. So, to calculate my cumulative frequency, remember I always start off with that first value there in your frequency column. So notice that is the value they started off the cumulative frequency column with. In order to continue, I need to add that next value from your frequency column. So I get 5 and 12, I get 17. Then 17 plus 15 I get 32. I'm just going to write 32 here. And then 32 and 19, it's 51. 51 and 16, it's 67. 67 and 10, I get 77. And 77 plus 3, I get 80. So I have completed my cumulative frequency column, and that is actually working out that part A there. Now, why did they say it's the customers who waited less than 5.5 minutes? Remember, my first class interval, it actually goes from 0.5 to 5.5. So 5.5 is going to be my upper class boundary. And if I am asked how many customers waited in line for less than 5.5 minutes, I'm going to say that answer is going to be 5. How many customers waited in line for less than 10.5 minutes? 10.5 minutes, remember, I have 5 customers as well as 12 customers to consider. It's actually going to be 17 customers. So I'm going to look across to my cumulative frequency column. That 17 means 17 persons waited in line for less than 10.5 minutes. How many customers waited in line for less than 25.5 minutes? I'm going to look at this class interval here, and my answer is going to come from my cumulative frequency column, and that answer is going to be 67. So 67 customers waited in line for less than 25.5 minutes. Now the second part of my question asks me to draw a cumulative frequency curve to illustrate the information. Now, when you are drawing a cumulative frequency curve, you are considering two sets of values. Your upper class boundary, and that is going to be plotted against your cumulative frequency. So on my graph paper, I'm going to draw up my axes. So I have labeled my axes. My y-axis is going to represent my number of customers, and my x-axis is going to be my waiting time in minutes. So now I am ready to draw my graph. Remember, for a cumulative frequency curve, I am plotting two sets of values, and that is your upper class boundaries as well as your cumulative frequency. So I'm going to write out a column with my upper class boundaries. Remember, your upper class boundaries are simply 0.5 more than your upper limits. So I have here now my upper class boundaries, and I'm going to be plotting that against my cumulative frequency. So as you can see, I labeled my x-axis with my upper class boundaries, so it's going to be easy for me to plot the graph. So my first point is 5.5, and I'm going to be plotting that against my cumulative frequency value there of 5. So I look for 5.5 on my x-axis, and there it is, 5.5, and I'm going to go up until I meet 5, and it is going to be right here. Remember, for points, we either put a dot and circle it, or we can use an X. So that's my first point. Next, I have 10.5, and I'm going to be plotting that against 17. So 10.5, I come up until I reach 17. That is going to be here. I put a circle. Next, 15.5, I'm going to be plotting that against 32. So at 15.5, I come up until I meet 32, and that is going to be here. At 20.5, I'm going to be plotting that against 51. So 20.5, I come up until I meet 51. That is there. And I continue in the same manner. So there you have it. You have all your points being plotted, and now it is time to connect those points with a smooth curve. And there you have it, your smooth curve from your points. Now when you are finished connecting your points, you must always connect that first point there with your x-axis. Now there's a way in which I can look for that value that is going to lie on my x-axis. So I'm going to look at my first interval here. I need to find my lower class boundary, and that is going to be 0.5, and that is how I'm going to connect that first point to my x-axis. So I'm going to look for 0.5, and that 0.5 is supposed to lie around here. So I circle that point, and then I connect that first point with that point there. And there you have it, your cumulative frequency curve. All cumulative frequency curves take a certain shape, and it looks as though it's a stretched out S. So a stretched out S looks like that there, and all cumulative frequency curves take that shape, and that shape is called ogive, spelt O-G-I-V-E. Now, part C is asking us to determine from the graph an estimate of the median. Remember, median is your middle value. You have 80 customers being surveyed. So to find that median on the graph, I'm going to draw a horizontal line through 40, because 40 is half of 80. So I'm going to look for 40 in my number of customers. There it is. I'm going to draw a horizontal line at 40 until it meets the curve. Now, from that point where the horizontal line touches the curve, I'm going to draw a vertical line to meet the x-axis. So at that point on your x-axis, you are going to read off that value, and that is going to be your answer for your median. And it looks as though it's lying somewhere around 17.5 or 18. So I'm just going to use 18, and that there is your median. Now we are going to do similar working to find out my upper and lower quartiles. So my upper quartile, I'm going to find 3/4 of that total customers, which is 80 customers, and 3/4 of 80 is 60. So I look for 60. I draw a horizontal line until it touches my curve, and then at that point, I bring down a vertical line until it touches my x-axis. And there you have it. Your upper quartile is going to be that value there where your line touches your x-axis, and that is about 23 minutes. So I'm going to write that underneath here. Your upper quartile, I'm just going to use UQ. Upper quartile is going to be 23 minutes. Your lower quartile, I use the same method in which I have been using to find median as well as upper quartile. But this time for lower quartile, it's going to be 1/4 of 80. And 1/4 of 80 is going to give me 20. I look for 20 on my y-axis. I'm going to draw a horizontal line to meet my curve. And at that point where it meets the curve, I'm going to draw a vertical line for it to meet your x-axis. So now at that point there, you have your lower quartile, and it is about 11.5. So I'm writing underneath here, your lower quartile is 11.5 minutes. Next part of the question asked the probability that a customer chosen at random waited for more than 16 minutes. Now, those customers who waited for more than 16 minutes include those who waited for 16 all the way up to 40 minutes. So what I'm going to do, I'm going to draw a vertical line at 16 minutes. So I'm going to look for 16 minutes on my x-axis. I'm going to draw a vertical line until it meets my curve, and then I come across until it meets my y-axis. So I've drawn my vertical line at 16 until it meets my curve. Now I'm going to draw my horizontal line until it meets my y-axis. So there is my horizontal line, and it looks as if it meets my y-axis at 33. Now, this number on the axis represents those persons who waited for less than 16 minutes. So to find the number who waited for more than 16 minutes, what I have to do is subtract this value from 80. And that is going to be that total number of customers who waited for more than 16 minutes. So 80 take away 33 is going to give me 47, and what they are asking in the question is the probability that a customer chosen at random waited for more than 16 minutes. So what I have to do is put that 47 over my total number of customers, and that is going to give me my probability. So I'm just writing it here. Probability is going to be 47 over 80. And the last part of the question, the minimum time for which 15 customers who waited the longest remain in line. So what I'm going to do is say 80 take away 15, and that is going to give me 65 customers. And at 65 on my y-axis, I'm going to draw a horizontal line until it meets my curve, and then come down with a vertical line and read off that time on your x-axis. So at 65, you see a horizontal line going across. It touches my curve. I draw a vertical line until it meets my x-axis. And at x-axis, I have 25. So that is going to be my answer for my last part. Thanks for watching. Don't forget to like and subscribe for more of my videos.